We're taking this, 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 we're taking with a pinch of salt.
Dear colleagues, welcome to The Pinch of Salt, a podcast brought to you by the ERA. I'm your host today, Dr. George Kosmadakis from Clermont-Ferrand, France, and the subject is liquid biopsies and AI goodies in nephrology. The future of nephrology is being shaped by two exciting frontiers: precision diagnostics and artificial intelligence. Liquid biopsies offer a non-invasive window in renal transplantation, enabling earlier detection and better monitoring of disease progression. Meanwhile, AI is increasingly used to analyze complex data, predict outcomes, and even guide clinical decisions. Together, these innovations hold the potential to transform how we care for renal transplant and CKD patients. We are privileged to discuss these advantages today with our distinguished guest, Dr. Valentin Goutaudier from Paris, France. Valentin, welcome to the Pinch of Salt.
Thank you, and thank you for this invitation.
Well, the pleasure is all ours because you are a big specialist. You had a wonderful presentation last year in the ERA Congress with a lot of people who listened to it. And the aim of the podcast today is to discuss all this interesting information that you gave us last year. So, Valentin, please tell me, what is the current role of liquid biopsies in renal transplantation and how they might complement the traditional diagnostic procedures?
That's a very good question. Regarding liquid biopsy, I think that there are maybe two main aims. The first one is to monitor rejection. I mean, using the liquid biopsy to detect if a patient has probably or not a rejection without performing any biopsy. Okay, so to avoid this invasive procedure. So there is a lot of data now in the literature supporting the use of some biomarkers in the blood, in the urine, to do this kind of thing. So we will discuss about this. The second point, and on this point, there is less literature, will be to use these liquid biopsy, these non-invasive biomarkers, as a complement to histology to guide the treatment of patients. So for the fourth step, the non-invasive monitoring of allograft rejection. So today we will talk about kidney allograft rejection. A lot of biomarkers have been studied in the blood, for example, donor-derived cell-free DNA, mRNAs, also in the urine, some proteins like the urinary chemokines, also some mRNA in the urine. There is a lot of literature. We have worked a lot on this in my previous research group, and notably during my PhD and my postdoc. And it looks like now there are two main non-invasive biomarkers which could be useful to non-invasively monitor kidney allograft rejection in kidney transplant patients, which are donor-derived cell-free DNA and urinary chemokines. So with donor-derived cell-free DNA, you capture injury. Okay, it is released by injured cells in the blood, and it has been demonstrated in large cohort studies that it allows a correct detection of both antibody-mediated rejection and T-cell mediated rejection. The second biomarkers are urinary chemokines, which are proteins detected in the urines, which reflects more inflammation in the tissue. And also some studies have shown that these biomarkers could be very useful to detect allograft rejection without performing any allograft biopsy. For the second topic, which is the guiding of treatment decision in complement to histology, you can imagine, for example, the situation where you detect, I don't know, for example, borderline lesions in the tissue, so an equivocal lesion in which you don't know using the standard of care what to do. Do you have to treat the patient or not treat the patient? We could imagine that we could use these biomarkers as an additional information in our head as physician to decide or not if you have to treat the patient. For example, if you have borderline lesion, you could, for example, perform a urinary chemokine test. And if it's elevated, okay, maybe means that you have inflammation in the tissue and you have to treat the patient. And if it's not elevated, maybe this means that there is not a significant inflammation in the tissue. And in this situation, you could avoid unnecessary treatment for the patient and avoid all the unfortunate secondary effects of this treatment.
So these markers have a diagnostic and potentially therapeutic options in order to optimize diagnosis, and also it is helping to guide therapeutic options in order to avoid potentially toxic treatments that could be unnecessary for the patient, protect the patient, which is another step toward the personalized care for transplant patients. And do you think, Valentin, that someday we might avoid these biopsies for our patients?
Well,
We can
that's a
get
good
to this
point.
stage?
That's a good point. So for now, as you said, the studies are more focused on the diagnostic utility of these biomarkers. Regarding the therapeutic utility, for now, it's more an area of research. So we don't have strong data to say that we can use these biomarkers to guide the treatment. But regarding the diagnostic utility, these biomarkers have shown very good discrimination and calibration abilities, with notably very good negative predictive values. And some centers now, notably some centers here in Paris, in France, who used to perform a lot of protocol biopsies, are now not totally avoiding, but significantly avoiding to perform these protocol biopsies in the transplant patient. So maybe for now, the first step is the avoidance of protocol biopsies. Regarding for-cause biopsies, maybe it's more difficult. For example, if you have a patient which has also a deterioration of kidney function with no obvious cause for this kidney dysfunction, I mean, maybe it's a bit complex to not perform a biopsy. I mean, we need additional data, but I mean, maybe it will be the next steps. But for now, a lot of centers in clinical practice are even totally stopped to perform protocol biopsies, or even significantly reduce the use of protocol biopsies to monitor the patient.
So as a guide for therapeutic options, it's early days for the moment, very promising, but early days, if I understood. But concerning diagnostic, you can see already the results in a very, very reduced burden of protocol biopsies, which is a huge percentage of the graft biopsy charge for the patients and for the clinicians. So this is really a trademark and a wonderful news. Is there anything else about the liquid biopsies or the markers that you would like to tell us?
I think that it's also important. So we have these new biomarkers, which are very innovative, which have shown very promising, let's say, methodological performances in large-scale studies, and which start to show interesting clinical value to improve the kidney transplantation journey. But if we want people to use them broadly, we need them to be easily accessible. Okay, so we need that we can send the samples to specific laboratories and to perform the test. And also we have to discuss about the cost, okay? Because obviously these biomarkers have a cost, which is, for example, more important for donor-derived cell-free DNA than urinary chemokines. So we have to look at the balance between the advantages for the patients and also the cost of these biomarkers. So it would be interesting also to have some cost economic studies to look if these new biomarkers, we have shown that they provide additional benefit clinical value for the patient, but now we have to also demonstrate that they do this without increasing the cost burden of the care of this patient, which is, I think, a very timely topic.
Of course, of course. It's always the same natural history of a new thing. You firstly describe whether it's interesting in the clinical practice, and after you are effecting a cost-effective analysis with the option that probably with large commercialization the costs might be reduced, and to see if it's more interesting for the systems of care that are severely under pressure financially.
Absolutely.
So now I will do a traditional question. Is artificial intelligence playing any role with all these biomarkers that you have stated?
Yeah, so regarding these, that's also an excellent question. When you assess the additional clinical value of biomarkers, you have to demonstrate that they do better than the standard of care. Okay. Because obviously, we are not using only clinical examination to detect kidney allograft rejection. We have already some biomarkers which are non-specific, serum creatinine, proteinuria, donor derived DNA. And so you have to demonstrate that these new biomarkers have an additional value on top of these biomarkers. So to do this, the traditional way is to first build a statistical model using the standard of care parameters to look if this model is able to detect or not allograft rejection. Then to build a model using only the innovative biomarkers, and then to combine them and to see if adding the biomarkers to the standard of care parameters provides benefit to detect allograft rejection. And so, obviously, by doing so, you are performing artificial intelligence because you are building models. So now we have also some models which combines these innovative biomarkers, whatever the type of biomarkers, and the standard of care parameters to detect in an integrative approach allograft rejection. So it has already been done in the literature. And so now prospective clinical studies and randomized clinical trials are needed to demonstrate that these integrative models are useful for the patient.
So you have created a macro system with models, with integrative models, standard of care models that you will use, I suppose, in any other comparative study that you will do in the future. And you have a cluster of new solutions that you include in newer models, and you compare them with the standard of care, which is an optimization of your research concerning these new biomarkers. And artificial intelligence, if I understood, is playing a central role in this huge amount of data processing.
Exactly, and these models are interesting because they make us think differently for the clinical decision for the patient because it's models. So they will not tell you if the patient has yes or no a rejection. They will give you an individual probability that this patient has or not allograft rejection. So that's why they are not independent clinical decisioners. They are a companion tool for the clinical decision made by the physician. So imagine you have a patient with a rise in serum creatinine, a DSA, you perform this test, they say you have a probability that the patient has, for example, let's say, antibody-mediated rejection or whatever, T-cell mediated rejection at 45%. Okay, so now you have to decide if it's significant to do or not a biopsies to confirm that the patient has really antibody-mediated rejection or T-cell mediated rejection. And so now we are also now in area when we have to prove which is the appropriate threshold to say that the test is positive or not. So it's also interesting.
Extremely interesting. It's the definition of a tool. The final decision always rests to the clinician, and,
Yeah.
and this is also securing our decisions in a certain way. Uh, how is apart from that, how is artificial intelligence being applied in renal transplantation? Are there any other promising areas of progress?
Yeah, in many ways, it has been studied to predict long-term kidney graft survival, to uh, uh, predict the mortality of the patient. Two others very interesting area in the field of precision medicine, which for me are very interesting, are precision diagnostics related fields. And the first point is the use of transcriptomic profiling of kidney graft biopsies to um, distinguish the different lesions in the allograft tissue. So this is the technology what we call molecular classifiers, which are machine learning models which use the transcriptomic data generated in the tissue, okay, to predict if the patient has or not antibody-mediated rejection or T-cell mediated rejection. This is an interesting tool in the situation where you have equivocal lesions again. So it means situation where the standard of care, including the standard histology, cannot allow you to correctly confirm a diagnosis. For example, borderline lesions, isolated vasculitis, microvascular inflammation below the threshold, or without DSA, without C4D deposition. All these situations where using standard histology and serum creatinine, etc., you cannot decide what to do for the patient. So in those situations, you can use this molecular classifier, which will also give you individual probabilities that your patient has or not rejection to improve your decision. So this is an interesting first step. The second one is the use of automated tools to correctly classify the biopsies. And for example, we have developed a tool which is the BANF automation system, which is a very simple AI-based tool which automates the rules of a BANF classification, because you know that to detect rejection now, the standard of care is the BANF classification, and now it's very complex. The rules are very complex, and the physicians, the pathologists, they do mistakes with potential deleterious consequences for the patient. So these tools allows you to automate the classification. So you have detected the lesions, and it will interpret the lesions to say or not if a patient has a rejection and the type of rejection. And this brings to the last point, which is interesting, which is digital pathology, another field. When you use deep learning to read automatically the slides of the patients, the kidney graft biopsy slides, and to automatically detect this time the lesions or if the patient has rejection. Okay, so now there is a broad interest in this, and this is a very dynamic area of research.
We had a podcast a few months ago with Professor Bahima from Netherlands, who is a renal pathologist, and she also told me about these future options. I even asked her whether her profession will become obsolete in the years to come, and she was not very reassuring. And so we talk about precision diagnostics, molecular classifiers, which is like a tool that elucidates the gray zones in the kidney biopsies, precision medicine. Automated tools that help classify the biopsies, which is extremely important, because I think that there is over 20% of wrong diagnosis with a new classification, if I'm not mistaken.
It's now 40%.
Even 40%.
Yeah, now it's
So,
the number that we have demonstrated in a specific study. Yes, 40%.
we absolutely need some help from digital tools, and probably sooner or later they will start reading the slides with digital pathology. So it's extremely exciting. what are the main?
And
Yes,
just to complete
please.
this, now you have also generative AI, which is
Yes.
a new field, but not totally new now. And so with generative AI, maybe you can do all this stuff with a single tool. So maybe all the tools that I have described to you during this podcast, maybe they will be useless in the next years because they will be replaced by generative AI tools. For example, studies have demonstrated that a chatbot um, uh, is able to automatically read um, biopsy slides to give a full pathologist report for some oncological lesions. So it's extremely promising, and I think it will probably transform the practice.
Oncologists are always one step forward in this matter, and usually when you look at what happens in oncology, you can think that sooner or later we will come to the other specialists.
Yeah.
But what are the main challenges in integrating AI tools into daily renal transplantation?
Well, I've a lot of challenges now because finally now it's very not easy, but it's not so complex now to code uh, to do this AI, machine learning, deep learning, LLM. Uh, Now the big problem is how to implement this in clinical practice. So the first step, obviously, is to develop tools which are methodologically correct. Okay, so you have to follow all the steps to be sure that your tool performs well in a population, but also in other populations. So an important part is to perform external validation studies of these AI-based tools. Second point is that uh, they have to be easy to use for the clinicians. So you will not provide a code to the clinicians; they will not use it. So you have to embed these AI codes into user-friendly application, which are easily accessible. The next point is that the clinicians, they want to trust these tools. So they have to be transparent. We have to avoid black boxes. And now, even in the AI fields, there are methods and rules to make these tools transparent. So it's possible, and it's very important because if a tool is not transparent, it means that the clinicians, they will not understand how these AI tools provide the prediction. I mean, which parameters are they using? Okay, so they could think that it's not correct. Okay, and then the last steps is also the cost again. Uh, it's important because the healthcare system is has complex economic issues now. And so we have also to be sure that implementing these tools in the clinical practice is not too costly.
So, Valentin, you talk about external validations, which is a standard procedure for newer diagnostic and therapeutic tools. You talk about user-friendly interface and a minimal, probably digital education of the clinical population, transparency, trust, and cost, which are very, very important. So if you have a blast to the future, how do you think, with all these liquid biopsies and AI tools, how will be renal transplantation, diagnostic and therapeutic be shaped in the next years to come?
Oh, big question. So first of all, I really think, maybe up, that these tools have not to replace the physicians. They are here to help us. I think it's very key, very important for all the people to understand that we have to develop these tools not as independent agents, but as companion agents. Now, the problem now is to also integrate these systems in the hospital informatics systems, in the APIs. So we have to work on this. Also, how to access correctly to the patient data in real time. I mean, we have to be sure that we are compliant with all the rules for patient data security. And then also all these models, maybe it's not necessary to have dozens of models for a single patient. Maybe we could combine them in virtual entities, for example, like virtual human twins, which could combine all these models in a dynamic matter with real-time updates for the patient using new data which are coming in his journey.
So you're talking about the integration of all these systems in the current digital informative system of care. And of course, you're talking about the consolidation of the models. That means that finally you will take the survivors integrated in a smaller number of tools, which is very, very, very interesting and very exciting. So that was my last clinical question. I will ask you our only get to know you personal question. Valentin, if you were in a desert island, which book, luxury item, and 2 songs would you take with you?
Oh, a book maybe the Odyssey, because this is absolutely beautiful text. A luxury item. Well, I don't really like luxury items, so I will bring a useful one, which is my watch. And regarding songs, 2 songs you said.
Yes.
The first one would be The Song Remains the Same by Led Zeppelin, notably the live at the Madison Square Garden in 1973. And the second one would be, I think, Wish You Were Here by Pink Floyd.
So
Beautiful,
beautiful choices, beautiful. And Odyssey, of course, it's a masterpiece. So, dear colleagues, as you can see, renal transplantation is entering an era where technology and biology converge to create new opportunities. By embracing liquid biopsies and AI, we may be able to provide more accurate, personalized, and proactive care for our patients. We hope this discussion has sparked your curiosity about the future of our specialty. We hope you enjoyed the discussion as I did. Valentin, thank you very much for being with us today. It was extremely interesting. Thank you so much. Dear colleagues, please stay tuned for more episodes of The Pinch of Salt, available on all known platforms. Please take care of yourselves. Thank you for listening.